Hello and welcome back to Calculus 2, Math 112. Today we have Lecture 17. The topic of the day is integration by parts. Integration by parts is actually the reverse of the product rule. You remember the product rule when you're taking the derivative of a product. The derivative of u times v with respect to x is u dv dx plus v du dx. We arrive at the formula for integration by parts by doing a little bit of algebra and integrating both sides. And then we have the result that the integral of u dv is uv minus the integral of v du. Let's take a look at an actual example. Suppose we want to integrate x natural log of x dx. So we let u equal the natural log of x. Du is dx over x. dv is x dx. So v is x squared over 2. If we substitute in the formula for integration by parts, remember the integral of u dv is uv minus the integral of v du. So we end up with x squared natural log of x over 2 minus the integral of x squared over 2 times dx over x. So we get x squared natural log of x over 2 minus the integral of x over 2, which is just x squared over 4, plus a constant of integration. Now here's another example. Suppose we wish to find the integral of x sine x dx. Whenever we have a polynomial, in this case just a linear one, times a trig function or an exponential function, we would like to be able to let u equal the polynomial repeatedly. This will yield a final answer. Sometimes we have to do it more than once. We have to apply integration by parts repeatedly for a few times. In this case, one time we'll do it. We let u equal x, so du is dx. dv is sine x dx, so v is negative cosine of x. So the integral of x sine x dx is negative x cosine of x plus the integral of the cosine of x dx. So the integral is negative x cosine of x plus the sine of x plus a constant of integration. Now here is a very interesting integral, the integral of e to the x sine x dx. So in this particular case we're going to use integration by parts twice, and we're going to generate a recursion formula. So the integral is I, the integral of e to the x sine x dx, and we're going to let u equal e to the x. Then du is e to the x dx. So dv is sine x dx, which makes v negative cosine of x. So I, the integral, equals negative e to the x cosine of x plus the integral of e to the x cosine x dx. Now we're going to integrate by parts again. This time we let u equal e to the x again, and du is e to the x dx. Now dv is cosine x dx, so v is sine of x. When we substitute in, we get I equals negative e to the x cosine of x plus e to the x sine of x minus the integral of e to the x sine x dx. But the integral of e to the x sine x dx is I. So let's write that down as an equation. What we've actually generated is the equation I equals e to the x times sine x minus cosine x minus I. So I can transpose the second I to the other side of the equation. I get 2i equals e to the x times sine x minus cosine of x. Just divide both sides by 2 and we have our final answer. The integral, which is the integral of e to the x sine x dx, I, equals e to the x times sine x minus cosine x over 2 plus a constant of integration. Now let's integrate x cubed e to the x. We're going to let u be the polynomial repeatedly. And in every step, that polynomial will go down in degree. So we let u equal x cubed. du is 3x squared dx. dv is e to the x dx. So v is e to the x. And in our first application, we get that the integral of x cubed e to the x dx is x cubed e to the x minus the integral of 3x squared e to the x dx. Now in the second step, we're going to let u equal x squared. That means that du is 2x dx. dv is e to the x dx, so v is e to the x. So then we evaluate that and we do the integration by parts one more time. And what we end up with is that I equals x cubed e to the x minus 3x squared e to the x plus 6x e to the x minus 6 e to the x plus a constant of integration. Now let's take a look at our final example. The integral of natural log of x dx. We don't know the integral of the natural log of x, but let's try applying integration by parts somehow. Why don't we let u equal natural log of x? Then du is dx over x. dv is just dx, so v is x. Now that's a very nice technique to sometimes let dv equals dx so that v is x. Whenever we're trying to find the integral of a function that eludes us, we might want to try this technique, because in this particular case it works very well. What we get is uv, which is x natural log of x, minus the integral of v du. So we get x natural log of x minus the integral of dx, which is just x, plus a constant of integration. And the final answer is that the integral is x natural log of x minus x plus c. This concludes this lecture on integration by parts. Hope you can join us next time.